Second.
Hello, welcome everybody for another session of Bitcoin smart contract using Script. So as I think in the previous courses, we have pretty much covered everything that's basic, how to write one, how to test it, how to deploy Coit, how to debug, how to integrate with your front end, and how to publish and verify all these things. So from now on, because since now you are already equipped with all the basic knowledge, so we are going to kind of switch gear, and we're most focused on some of now you know how to write, and hopefully you have mastered SQL smart contract. The next set of problem is, hey, what kind of things can you do with it? So we are going to almost like doing use case studies from now, which I think is going to be very interesting to at least give you some idea, what kind of things people have built, and hopefully to give you some inspire you to use it in more innovative ways, create your own contracts that nobody has come up with before and can solve real world problem. That's will be our objective from now. Okay, so today I'm going to show you this, so-called auction application. Basically, is a English auction. Whoever's offers the highest bid, he can win, right? So in this tutorial, I'm going to cover you how to build such an auction contract, which could be very useful, right? You can see all kind of potential advantage why you want to do a contract. For example, it's transparent because everything is on chain, and also because it's in contract, nobody can cheat, right? Because if you can make sure nobody's going behind the scenes. You know everything, so it's fair and transparent. You can trust the result, and also you are sure if you offer the highest bid, you can always win. Actually, you got the delivers whatever is being auctioned. Okay, so let's dive into the contract itself. So the contract works this way. As I said, it's an English style auction. So you have so to give an example, let's say you have a UTXO, right? It could be, usually represent some kind of like a real world property, or even it's just a token. You can think of once you lock some UTXO using this contract, you can think about the UTXO. It's almost like a token. It represents something of value. Okay, could be like an FT, could be, represents the painting or house, whatever you can think of. And then the process is as follows. So it has a minimum bid, and then whoever offers the higher bid, he will be the current owner of the auction item. And then this process can keep going, right? If somebody else comes with higher bid, he can take over. Then two things happen. One, the higher bidder now become the current owner, but also at the same time, we have to make sure the previous, highest bidder, he's got refunded, okay, automatically. This is all guaranteed by the contract itself. So you don't have to trust some kind of third party to return your money if you are not the highest bidder anymore. So this is obvious benefit, right, to do this in a contract. And the last one requirement is there's a deadline. Okay, so if here everybody can participate, but we want to set a deadline. So after that, the auction is considered over, and whoever has the highest bid up to that time, he is a legitimate owner of the auction item. Okay, is this clear? I mean, the use case.
Yeah, that's clear. Only one question. So could it be as well that after each bid, the deadline is extended by, let's say, 3 minutes, so other people have time to bid, and they don't always wait until the last second?
Oh yeah, that's that's a great I would say extension. So here, when I say you can close by the deadline is absolute, right? So you can also set it such that, every time somebody bid, it's like you have countdown, right? So now everybody, if within, let's say 3 minutes, if somebody else is bidding, and then the deadline extended by another 3 minutes, and this keep going. If nobody bids in this window, then it's considered closed. You can also program it that way too. Yeah, great, good idea. Yeah, but for now, for this example, I use an absolute timeline, just make it simple. But you can definitely use whatever you just proposed as it automatically, refresh. Let that know. Okay. So
Cool,
let's say how. Okay, no problem. So let's keep going. So obviously, first, when you design a contract, you have to say, okay, what kind of properties have, right? So obviously, you can have, say, auctioneer, whoever is hosting this. Eventually, you got to pay this guy, right? So this is, you can think of the, whoever is hosting the auction, the auctioneers. You want his key, and also you want the deadline. Could be block height or could be Unix timestamp. Okay, and also we also have this property. I think this one I want to highlight. So basically, it's a property, as we learned before. If it's the parameter set to true, that means there's a stateful. So that means it can be updated even after it's deployed. So this one is the current highest bidder, because multiple people can bid. So this one we want to make it mutable. Okay. So as before, you can, it's constructor, nothing special here. You can just initialize all these parameters in the constructor. Okay, nothing surprise here. And let's look at the bid process, right? So we have two actions here, right? So one is, whoever really want to buy it, they can offer a higher bid. So this is the bid option. We have another one, basically says, hey, now the auction is over, let's close it. So in this way, the auctioneer get paid. Okay. So let's look at the bid. So we have a diagram here, make it easier. So once you lock up some kind of UTXO using the deployed using the contract. So let's say we have the current bidder, the highest bidder. Let's say now it's Alice, and he is offering, let's say, 10 Satoshis. Okay, and then Bob come here and say, hey, I want to offer 20 Satoshis. Okay, so then the bidder, right, get updated to Bob because he's putting 20. And then we have another, okay, this is one transaction. So this on the left are inputs, on the right are outputs. Okay, so in the input, of course, because we are going to bid on this, so we are spending the current UTXO, and we are updating the current bidder to be Bob because he's offering 20 Satoshis. But at the same time, this one is also very important. We have to make sure there's a refund to Alice. Okay, Alice, he gets refund of his 10 Satoshi he put before. Okay, and of course you have, the one, because Bob is bidding, so he he wants to get some, inputs to cover the transaction fee. And then because it may not be in full amount, so he also could potentially get a change output. Okay, so is this transaction structure clear? I think that's why it's better to draw it out. Make sense?
Yeah. Yes, it is. Yeah.
Okay, sounds good. All right. So the same thing, right? It can be repeated. What if Charles offers 30 Satoshi, right? So he repeats the same process. Now he becomes the current owner, and the 30 Satoshis goes into the UTXO. Bob gets refunded, and then you have some, transaction fee related inputs and outputs. Okay. So let's translate this into actual contract code. Okay. So, because we already covered, the concept of a script context. Okay, so we can easily, in this way, because we can have a context, it contains the UTXO information, so we can easily get, hey, what's the current high speed? If we run it here, it's going to 10, right? And if we run here, it's going to be 20. So when you bid, of course, you want to provide how much, what's the amount you are bidding, okay? So this is the current bid amount. So if it's higher, we make sure it must be higher, right? Because it's English, style. You want to make sure this is good. And then you also want to update, what's the current, this is the current one, and we want to update it using the new bidder, okay? And once we have the bidder, now we can, create the new output, because this is the stateful contract. We just create this new stateful output, and with the updated state, the bidder now is updated. Okay, so this is the output. This one is creating the output. This is the auction output, which is highlight. Okay, using the script context we have used many times before. And then the next one will be refund, right? You can, because we have the, let's say, for example, here, Alice is a public key, and also have Alice, previous bid amount. So we can create an output, so-called pay to public hash. Public hash, we can say, hey, this is Alice, and this is the transaction. This is the second output here. And then we may have an optional, if there's remaining change, we can say, hey, this is the change amount. Okay, we can build this. So once we have all the three outputs, we can concatenate all of them, right? This is the outputs we're talking about. So we can concatenate all of them, and then we use the, script context hash trick we have already used, right? Because the script context has a hash of outputs. So if we assume this corresponds to the current transaction, we can hash it and match it, make sure this matches. Okay. Any question about the bid process, which is, I think, the core function of the contract?
No, that's okay.
Is it good? It's good? Okay, no, that's good.
Good, thanks.
So this is the bid process, we just covered. And this is the final code. You can see, let's just briefly review it, right? So when you bid, you have to offer, hey, who is bidding, identified by this public key, and how much you are putting into this, okay? So you want to make sure, this is a higher bid, and also all the three outputs are good. So you do this by checking here, okay? So that's good. So once we have, the bid, what if now we have come to the point, it's keep bidding up, and then one more, the auctioneer says, hey, now let's close this, and I want to get paid, and you got to be the legit owner of the UTXO or whatever is represented. You can almost think about it as a token, right? It can be, all kinds of tokens, whatever, if it's UTXO based, okay? So this is how the last bid, went over. So you have a highest, and then you have higher, you got the new highest bid. And now, because the time is over, you want to make sure, okay, now the money can be transferred to the auctioneer, okay? So this is the final, the closed transaction. You see that it has a different structure than the bid, right? Because now you are not updating a refund, you are just closing it. You basically transfer the money to the auctioneer, okay? So the way you do this is you only need to check two things. One is make sure the deadline has passed, okay? Because in the script context, for people, if you want a brief reminder, so we have a script context here, containing a lot of extra information other than whatever is passed in the public method arguments. Right? So this is a context. So we have used, the hash outputs to make sure the output is what we want, and we have used the UTXO to get, you know, a lot of, let's say, the Satoshi information out there. And that's also, which we haven't covered before, is this have a log time field. Basically, this is a log time field of the current spending transaction. So basically says what is the earliest time this transaction can become valid and be accepted by miners. Okay, so if you want to know more about log time, this is there's a link that has the detailed explanation in our wiki. But basically, this is, you can think about this is the earliest time, like the earliest valid time for this transaction. So you have to make sure this does exceeded the deadline. And once that happens, you also have to make sure, hey, you know, only the auctioneer can take the money, right? You don't want everybody, you don't want anyone to close this, right? Because then they can steal the money, right? You want to make sure, hey, you know, you got the signature from the auctioneer. Hopefully this auctioneer can have this valid signature. So you want to make sure, hey, this is actually the auctioneer signing off. So we are good here. Okay. So, you know, this is the final code. I think this is much simpler because there's no state, you know, update here. So you just briefly review, you want to check deadlines reached, and also it is actually spent by the auctioneer, identified by his signature. Okay, is this good for now? This one, the close?
Yeah.
Okay, sounds good. I think normally this will be over, but because here there's some special things going on, because usually when we call a transaction, update the state for transaction, you only go to one and then you have change. So just a brief reminder. So if you want to call a transaction, you know, usually this is, if you want to call it, so this is we have a default format. So, you know, the first input has to be the contract UTXO, and also the first output also has to be the contract output. And then there's a change output, okay? If you compare this diagram to this, right? These two are not, this format doesn't conform to this standard. Do you see what I mean? This is a contract. Usually if you're on the default format, yeah, there's no refund output, right? So that's why we cannot use the default one, which is, you know, easiest one and covers a lot of use cases, but not for now. You have to, because it doesn't conform this, so you have to customize it. Okay, the way, again, you know, if you use if you consult the documentation here, if you want to customize it, you use the bind transaction builder. Okay, that's exactly what we do here. So you can bind a transaction builder. Okay, and within this, you are creating your own transaction format, because it doesn't conform to the default format. So you have to build your own. Okay, so this is one you have to override this one. Pretty much, you can say instance dot bind transaction builder, and then this is a method name. Let's say here we are overriding the bid, right? The bid transaction and the bid public method. So we have to say this is bid, and then you have to give it another parameter called options, which tells it how to build the transaction. Okay, so this is the transaction we are building. We are again using the BSV in the module. So you are creating the transaction. It has certain inputs. It has, you know, this is the output, the stateful output, but also you have the refund output. Okay, so refund, this is the how, as we said earlier, it's almost equivalent to whatever is a contract. So it's the output. You have to tell it what's the current bidder and also what's the Satoshi is getting. You know, what's the current Satoshis. Okay, and then lastly, you have a change output. So once you build this, now you can, everything is ready to go. I think this is the full code here, as you can see. You know, we even put some examples here. You know, this is the bid public method. This is close, and this is the the builder we need to bind to, because we're not using the default transaction format. Okay. So this is, again, we just covered the how do you customize the transaction. Okay, the bid transaction. Okay, this is the end of the auction. Any questions, comments? Is this easier than what you think, or how do you want to modify it to do?
One question. So, at the end of the bid, at the end of the auction, how many transactions have received the owner? One of value 10, then another one value 10, and the last one, or it only received the last one? Because at that part I wasn't sure. Do you know what I mean?
Yeah. So whoever is paying the current highest is always locking up his bid amount in the latest UTXO. So the auctioneer, when he takes the gets once get paid, he only spend the last one. Is that what you're saying? Maybe beginning start at 10, maybe 20, and then build up to 30. So if he wants to close after, let's say Charles, he just spent this one. The previous one is already refunded. Is that what you are asking, or?
Yeah. So
you only spend this one. You don't spend all this.
Yes, but this no. So that was my question. So the previous the change is a self transaction. So it's going back. I don't know if I can explain it. Well, my question is, I didn't know if the owner will receive 10 from the from the first bid, 10 of the second, and 10 of the third, or if he received 30, then the refund of 20. Where is this 20 coming from? From UTXO?
Yeah, this one
Does
is
it make
coming
sense?
from the. So you're saying, where does this 20 come from? For example?
Yeah, exactly. So yeah, this 20 comes from Bob UTXO,
Bob.
right?
Yes, here. That's this one. Yeah.
Yeah, and the refund to Alice comes also from Bob UTXO, or
No,
comes
from here.
Alex UTXO?
From here. Yeah.
So that's what.
So here's the thing. Yeah. Well, beginning, when you have Alice, right? Before this, you have Alice, right? So he gets let's say the minimum amount is 10. So let's say the first bid, that's a missing transaction. If you want to, finish this full sequence, there will be a bid by Alice. He pays, let's say, he has an input here, cover the 10 and also get the change and the transaction fee. But he going to cover the 10 here coming from Alice's UTXO. And then once after Alice is the same, Bob is the same process. This Bob, the money, this 20 come from here, and also the change also goes back. Do you see what I mean? So the Alice get exactly the amount he has bid before. So he got refunded fully.
Refunds are self transactions. So it's coming from the Alice
from here.
UTXO to Alice wallet. Okay.
Yes, yes, because
yeah. Please go ahead.
Yeah. So Alice, because when you bid, you remember Alice's public key, right? So here you can make sure nobody else gets refunded. Alice got refunded, and for the exact amount he has paid. So basically means if you're not, your auction, you propose your bid and somebody is higher than you, then your bid is like invalidated, right? You got exact amount back. The here saying there's no auction house, there's no source bid. You are guaranteed. You don't have to worry about it. Make sense? Because otherwise people can steal your money, right? Refuse to pay you, right? Because this is a way, you can do this completely trustlessly. Okay. Any other question?
Yeah, the other question. I mean, I get this is an example, but Just imagine that we have this very same example in real life. So it can be all the bits can be in the same minute, basically. So you bid, the transaction goes to the mempool. Then we may have several people bidding. The first transaction arriving, I guess, will become the highest bidder, regardless of the amount. So if we have Bob and Charles bidding against Alice, if Bob transaction is seen first, Bob is the highest bidder, and then Charles will need to bid again on top of Bob's
yes.
Bob's bid, right?
Yes. Yeah. Okay, exactly. So this, in practice, there may be a problem, because if multiple people are bidding and there's only one current UTXO, right? All of them have to spend from this one. So here's the thing. That's why I think this use case is okay, because if you have higher bid, if you let's say Bob and Charles bid at the same time, and then Bob's transaction gets accepted first, and then Charles will be rejected, right? Because even though he has 30, but his UTXO spending here is already spent by Bob, right? But then no problem, right? He will get notified, oh, my bid failed, so I have to rebid. So because he's higher, so he's going to win. Unless this is like a last minute, this is like the close to the deadline. I think you may have some educators, but here's again, right? In order for this to conflict, you have to be within like maybe a second of each other, right? So this is very difficult and auction, we are not supposed to have like thousands of people bid at the same time. I think it's that, yes, the problem you have mentioned, if it's like a very high frequency kind of activity, you could have this concurrency issue. But for here, bid, it's probably not going to be like a milliseconds level and keep going for like hours. So if you have higher bid, eventually you're getting. So but the problem is not the problem, but you have to, when you design the app to let's say front end for this, you have to make sure sometimes it can fail, because you may have two people almost be at the same time, right? So you have to then to have the failed one retry it. You have to remind the user and to retry it. Okay, but yeah, good point. Yeah.
And maybe a third question. So this could be, I guess, integrated with some Oracle to either take the information from off-chain, or even send this information to off-chain, right?
Yes. Yeah, exactly. Like what we covered last week, right? We talked about oracles, and because this is a simple one, we just say, hey, every information is coming from on-chain, right? The bidder and the current high speed, right? You could imagine, hey, depending on, let's say I don't know, like the weather or some sporting events outcome, you may have different outcomes for all this different bid, right? So you can then import all this information using the oracles we talked about last time. Yeah, it's modular, right? This is only a bidding module, but you can definitely combine this together with other modules such as Oracle. Yeah, very good point. It's very extensible.
Okay, cool.
Cool.
No more questions.
Anything else?
No, I think that's fine. Yeah, that's great.
Okay.
Great example.
Okay. All right. Very good questions, and keep them coming. So, okay, I think this is what we're going to close here today, and we covered the auction. I'm going to put the link in the show notes. So yeah, from now on, I think this is the first use case we talk about, and from now on, we are going to cover all kinds of very interesting and hopefully insightful use case for you to build upon. Okay. All right. See you all next week. Bye bye.
Yeah, thanks. Bye.